Bonsuelo, mathletes. Okay, today we're going to do more on radicals. What's going to be different? Well, actually, the process is not going to be any different than what we've done before. What's different is we're going to be looking at indexes, in other words, roots, that have numbers larger than 2. In other words, up to this point, we've just looked at square roots. Well, we're going to look at cube roots, fourth roots, fifth roots, etc., etc. And the most important thing you need to know is this, that you take the index and you divide it into the radicand exponent, which is basically what this says right here. Okay? In other words, just to show you something real quickly, if you have the fifth root of x to the 30th power, that's going to be x to the 6th power. Why is that? Because 30 divided by 5 is 6. So we take the radicand exponent and divide it by the index. So 30 divided by 5 is 6. That's the basic idea, okay? And again, the terminology, the index, the root, the radicand, the radical symbol, that's all the same. This is the same, okay? To give you an example, again, what you do is you factor completely. Here's 96 factored. And then we're going to separate it into things that we can take the fourth root of and things we can't. So we can take the fourth root of 2 to the 4th with the 2 left over. We can't take the fourth root of 3 to the 1st. Of the x to the 19th, the largest thing we can take the fourth root of is x to the 16th. And that leaves us with 3 left over. And of y to the 26th, we can take the fourth root of y to the 24th. Why? Because the 4 divides evenly into all of these exponents. And it's the largest thing, okay? But it won't divide into any of these exponents. Okay, so we're going to take this and divide it into each exponent. So 4 divided by 4, meaning this 4, is 2 to the 1st. 16 divided by 4 is going to give us x to the 4th. And 24 divided by 4 is y to the 6th. And then the fourth root of 6, x to the 3rd, y squared is what you have left over, so that just stays under the radical. Okay, so we're just going to take a look at some of these problems. First of all, remember that when there's no index written, it means it's a square root, okay? So there's no index there. That I didn't intend that to be a 0. I was circling the fact that this was 2, okay, even though it's not written, okay? So we're going to take, and you don't need to write this part, we're going to take x, and then it's 28 divided by 2, which will be x to the 14th power. In this case, we've got 28 divided by 4, which is x to the 7th power. Now, in this case, a square root, we have to separate it because you can't take the square root of the 32 or the x to the 15th. So we have to separate this into things we can take the square root of and things we can't. So for the 32, we can take the square root of 16 with a 2 left over. And the x to the 15th, we can take the square root of x to the 14th with an x to the 1st left over. So the square root of 16 is 4. The square root of x to the 14th is x to the 7th. And then with the square root of 2x left over. Okay, the fifth root, though, of 32x to the 15th, that we can do because the fifth root of 32 is 2, and the fifth root of x to the 15th is x to the 3rd. Okay, so you have to make sure you know what the index is on these. Okay, the cube root of 8 is 2. The cube root of 125 is 5. Because remember, it's what number times itself 3 times gives you 8, that's a 2. And what number times itself 3 times gives you 125, that's a 5. Now, this will be the fifth root of 4 times 8, which is 32. But you know, better than writing a 32, it's better to think of this as 2 squared, and this is 2 to the 3rd. So 2 squared times 2 to the 3rd is 2 to the 5th, or 32, and the fifth root of 2 to the 5th is 2. Okay, here, don't start rationalizing the denominator. What you want to do is cancel. So 2 goes into 250, 125 times, and x to the 8th cancels with x to the 29th to give you x to the 21st. So cancel your fractions first. And remember, that's assuming there's no plus or minus between any of these things. So what's the cube root of x to the 21st on the top? X to the 7th. The cube root of 125 is 5. Okay. How about here? The 6th root of what? Well, this is 2 squared. This is 2 to the 4th. So it's the 6th root of 2 to the 6th, or if you want to call it 64, that's fine. And then we're going to multiply x to the 5th and x to the 9th and get x to the 14th. Okay? Now, we can take the 6th root of 2 to the 6th. We can't take the 6th root of x to the 14th, though. Okay, so what we have to do is we'll leave the 2 to the 6 as it is, and we'll split up the x to the 14th and what we can do and what we can't do. So we can take the 6th root of x to the 12th, but not x squared, which is left over. So the 6th root of 2 to the 6 is 2, the 6th root of x to the 12th is x squared, and the 6th root of x squared is left over. Okay. For this one, number 9, this is x to the 60th. I'm not writing this on every problem because you can just take 12 into 60. And then this is y to the 48th, 48 over 12th power. So that's x to the 5th, y to the 4th. Okay, here, we can't take the 7th root of x to the 39th because 7 doesn't divide evenly into 39. So what we can do is take the 7th root of x to the 35th with an x to the 4th left over. And then we can take the 7th root of y to the 63rd with y squared left over. So the 7th root of x to the 35th is x to the 5th. 7th root of y to the 63rd is y to the 9th. And we have the 7th root of x to the 4th, y squared left over. Okay, the square root of 8x to the 15th. Again, we have to split it up into what we can and can't do. So we can do the square root of 4, but not the 2. And then we can take the square root of x to the 14th, but not the x that's left over. So the square root of 4 is 2. The square root of x to the 14th is x to the 7th. And then we have the square root of 2x left over. Okay, the cube root of 24. Well, we can't take the cube root of 24, but we can take the cube root of 8, because 24 is 8 times 3. And we can't take the cube root of x to the 23rd, but we can take the cube root of x to the 21st with an x squared left over. So the cube root of 8 is 2. Cube root of x to the 21st is x to the 7th. And then the cube root of 3x squared is left under the radical. Okay, here. Now I'm going to review a little bit about rationalizing, and I'm going to do it down here so you don't get the idea that I'm doing any of these problems. Remember, the idea is, let's say you have 5 over the square root of 7. Okay? Well, what do? You multiply by square root of 7 over square root of 7. Why? Because that gives you 5 square root of 7. Oh, and you don't normally write this step. That's why I'm kind of doing this off to the side. 7 squared. Okay, well, what's the square root of 7 squared? It's just 7. Okay, that's the way it works. Everyone skips this step right here and goes straight from that to that, which is fine. That's what I expect you to do. Well, what's different about this? Okay, notice if I just multiply by, this is not good enough. If I multiply by 3, the 4th root of 3, on the bottom, so don't write this because this is not correct. You get that on the top, but on the bottom you only get the 4th root of 3 squared. And you can't get the 4th root of 3 squared because this exponent has to be at least 4. So that's not good enough. So what can you multiply? Well, right now that's 3 to the first. So we need to multiply this by 3 to the third to get it to be 3 to the fourth. So we have the fifth root, and you can skip this step, not the fifth root, sorry. 5 times the fourth root of 27 all over the fourth root. This is now 3 to the fourth. And the fourth root of 3 to the fourth we can do. So it's the fifth root, not the fifth root, sorry. 5 times the fourth root of 27 all over 3. Okay? Now here, you might be tempted to multiply by the fifth root of 4 to the fourth power, which normally would be okay. Like, let's say this was this. I'm going to write something down here, but you don't need to bother. Let's say this was that, okay? You'd multiply by the fifth root of 2 to the fourth, because that'll get you a 2 to the fifth on the bottom. Okay, and then that would give you the fifth root of 16. This is not this problem 14, though, so be careful. And that would all be, sorry. This should have been a 4. Okay, and that would give you the fifth root of 2 to the fifth, which would then lead you to the fifth root of 16. Don't write this down, though, because we're not going to do this. That looks like a 25, doesn't it? Should be 2 to the fifth. And that will give you 2. Okay, so fine. That's what you do. Let me get rid of this, though. So why aren't we going to do that on this problem? Because what you got to realize is this is already 2 to the fourth. Sorry, it's not 2 to the fourth. I wish I could talk. This is already 2 squared. So what do I need to get that exponent to be? I need to get it to be a 5 to match the index. Well, in which case I'm going to multiply by 2 to the third. So we get the fifth root of 2 to the third over the fifth root of 2 to the fifth, which gives us the fifth root of 8 all over 2. So remember, your first thought is factor, so I factored the 4 and called it 2 squared first. Okay, here, what do I want? I want the 10th root. Now, right now it's x to the 7th. I wanted to get it to be x to the 10th, so I'm going to multiply by the 10th root of x to the third, top and bottom. So we get the 9th root, 9 times the 10th root of x to the third, all over. And this will give me the 10th root of x to the 10th, which is just 10. Okay? Oh, gosh, I wish I could talk. I'm like an idiot here. Okay, no, that is not correct. It gives me the 10th root of x to the 10th. And what's the 10th root of x to the 10th? Just x. Okay, here what do we want to do? Well, we want to get the exponent here to be 12. So I'm going to multiply top and bottom by the 12th root of x to the 7th. So we get the 12th root of x to the 7th all over the 12th root, and x to the 5th times x to the 7th is x to the 12th. So the 12th root of x to the 12th will give us just x on the bottom. Okay. So what we're dealing with here is larger indexes than 2, but basically the process is the same. Again, what you do is you divide the index into the radicand exponent, like we did right here. 4 goes into 4 once, 4 goes into 16 4 times, and 4 goes into 24 6 times. Okay? Have a good day, everybody. See you next time.